So there are numerous analyses that you can conduct on different tests, and so we went over frequencies. Let's take a look at crosstabs. That's one of the ones you would look at if you're wanting to do run the analysis, the chi-square. And you can look in your workbook, and there are several procedures that you can do, different tests. So we're just going to look at any combination of nominal level or ordinal level variable, and then run a quick analysis. So again, I just went to Analyze, Descriptive Statistics, and then I went down to the cross tabulation tab. Okay, so I selected my two variables, and when you're looking at this, the column view will be your independent variable, and your row will be for your dependent variable. So what you're saying in a sense is that people are likely to, people who accept others even when they do something wrong, will be associated with the respondent being not married. All right, so we'll run that analysis, and there are a number of statistics that you can choose here. We're going to call up our clustered bar chart, and that's the one that you would be appropriate to use with two variables, so bivariate data, when the independent variable and the dependent variable is any combination of nominal and ordinal. All right, so we're going to look at chi-square, and like I said, there are many, depending on how many levels of the variable, as well as what the level of measurement is. Okay. And you can certainly look at observed and then expected, and then get the percentage of the row, the column, total, or whatever is of interest to you. It depends on your preference. All right, so we'll run that, and you can see, again, this is like the frequency here, number of cases missing, and this actually goes way out, and I'll just kind of scroll over so you can see. The independent variable accepts others even when they do something wrong, and your dependent variable is in the rows, and you have all of the levels of that. So yes, no, and some others, if they have any others. So we just have two. Okay. So, and then you can look at what that means many times a day, every day, most days, some days, once in a while. That's how often a person will accept others even when they do something wrong. Okay, and I just want to point your attention to the chi-square. This is where you find that test statistic. And a little further down in your lesson, you'll understand that the p-value, if it's 0.05 and under, you have support for your hypothesis. And you can see that we're not able to reject the null, that these two are, that there's no association. Okay. And this is a very colorful representation of the different categories here. And when you're looking at, the clustered bar chart gives you a little bit more detail. It gives you information about each value, each level of your variable. Okay, and the legend will represent in colors what the other variable is, so this independent variable. So now I'll go to compare means, and there are several here, and I'll just go over one just to show you where the procedures are, and we'll look at the independent t-tests. Okay, so looking at marital status and number of children. And again, you need to have a dichotomous independent variable, so the independent variable needs to have two categories only. And then your dependent variable needs to be continuous because you're comparing the means across these two levels of your independent variable. Okay, so this is where you'll find the sample and the number of each in each group, the mean. So if you predicted that those with who are not married, yes, would have more children, you would not have this wouldn't be in the direction of what you're predicting so far. But say if you said people who, when asked if they were not married, they said no, had more children, then so far you're moving in the right direction. Okay, standard deviation, this talks about the spread of the responses, and we'll just go to the results here. You look at your significance level. When you assume equal variances, you can go to this area here. When they're not any of, pretty much it's just looking at the number of folks in each group. I think typically if it's no more than 1.25 more than more or less than a group, then you're in good shape. So we'll take a look at this, and your significance is 0.000. So that means that the results are statistically significant, that there is this difference here between the means. This is significant. All right, and there's some other information here in terms of when you're doing hypothesis testing, the confidence interval will tell you like within a range that you can declare certainty. And I just want to give you an idea of some analyses that you might use. And I've just kind of done one, so I'll just do it again. For if you want to have a look at how two interval level data variables are related, you would go to this procedure called bivariate correlation. And this is considered the Pearson's R. And then we have a number of others, the Spearman's rho. For instance, you would use that if you have two variables that you want to look at the relationship between, and they would both need to be ordinal level. So an ordinal level independent variable and an ordinal level dependent variable, and you would choose that one. So since we're looking at two variables that are interval level, we're going to go with the Pearson's R. And your instructor can talk to you about two-tailed, one-tailed, but if you have a really good idea that the direction of this prediction is based on some scientific knowledge or something that you've seen again and again in practice, and you're pretty sure, you can increase your power by proposing or conducting a one-tailed test. But if the results are in either direction, if one of these are higher or predicts or follows from the other, if that's important to you, then two-tailed is just fine. Okay. And so this is the output here, and you should see this as well in your workbook. This is the Pearson R results, and that is pretty weak. It looks like it's next to like hardly related. So keep in mind that when your Pearson's are, it's a range from -1 to +1, and when it gets to the center 0, when R equals 0, that means no relationship. So the age of respondent is not really related to the age the child is when it's first born. Further, the results are not statistically significant. So this is the p-value is over 0.05. And I just wanted to point out also that you can run your ANOVA or your analysis of variance for a one-way ANOVA by going to compare means. We did the t-test. The extension of the t-test is the one-way ANOVA. Okay, and you would just select where it says factor, you would put your categorical or your independent variable here, and then you would put your interval level or your dependent variable in this block. All right, and what I would suggest is then go to, I'll do that a little slower, go to post hoc, click the Bonferroni, and what that will do is also not just give you what information about whether the model is significant, but it'll actually tell you the differences between each level of the variable and how they're related. Okay. All right. I think that's it. So I hope this is helpful.